All right, so this is going to be a quick lesson on how to do a weather map just with a station model. Now, the station model actually uses a circle that represents the sky, and then it uses a line to indicate wind speed and direction. It also is able to give you the temperature up in this little side over here. It's able to give you the dew point, the visibility, the pressure, the barometric trend, whether or not the pressure is going up, is the pressure coming down, is it staying constant? And then it gives you the precipitation. So from this little model, it gives you a bunch of different bits of information, and you should be able to tell exactly what the weather is doing at that spot. So let me go ahead and just sketch one of these out for you. And I think I'm gonna leave it at that. All right. So obviously there's a bunch of numbers there, and it probably looks really confusing, but it's actually not that confusing at all. I'm going to just slip into the frame your station model explanation. Now this is actually on page 13 of your Earth Science reference tables. So this is on the same page of as your temperature scale and your barometric scale over here, and it actually has a station model explanation. And what you want to do is you want to think of this as a clock. All right, so you want to think of it as a clock with all of these numbers being at different periods of time at the clock. All right, so this first one, this is probably at 11 o'clock. We have our temperature right here. So at maybe 11 o'clock, we'd have our temperature. Now notice, it not only gives you the position of this, but it also gives you the units. So you need to be really close and careful with that. So temperature is going to be in degrees Fahrenheit. So my temperature for my scale that I drew, my temperature, looking at 11 o'clock, is 75 degrees Fahrenheit, just because I see the 75 there and I know it's measured in degrees Fahrenheit. Sorry about that. We're going to continue on from there. The visibility is the next one, and this is always in miles. So if I went to the station model that I just quick sketched out, I found my visibility is the next one. This is at 9 o'clock maybe. My visibility is going to be 10 miles. Again, I only know it's miles because it says it right in my reference tables. This station model, the purpose of it is really just to simplify it down. So in order to be able to put it on a map. So they took away the units and just left the numerical values there. My next value down, if I went to maybe 8 o'clock, is dew point, which is also in degrees Fahrenheit. So my dew point is going to be 60 degrees Fahrenheit. So far, so good, right? Not too hard. The next thing that I'd like to use is I'd like to do the wind direction. Now, the wind direction is where this little staff is pointing. So if we thought of just a normal compass scale, with north being up here, south being down here, and west and east being over here, this post is positioned sort of up into that northeast direction. So wind direction, now be careful here, this actually would be from the northeast. Wind is always named by where it's coming from. We only care about where it's coming from. That's the only thing that matters to us, because if it's blowing in from the northeast and it's bringing cold air with it, then it's going to bring cold air to us. Or if it's bringing wet air, it's going to bring wet air to us. We really only care about what it's bringing to us. So we're only focused on where this wind is coming from. What I like to get in the habit of doing is extending this arrow through, and that's going to give you a direction to the wind. So this wind is moving from the northeast to the southwest. So do you see what I just did? I just extended this, I call it a lollipop stick all the time. I extended the lollipop stick through the lollipop and out the other side, and you can clearly see where it's going to now. So it's going from the northeast to the southwest. All right. We can also do wind speed. Wind speed is determined by these little feathers, and it actually tells you right in your reference tables. It also tells you from the southwest, but it tells you how to determine this wind speed. A whole feather is equal to 10 knots and a half feather is equal to 5 knots. So in the reference tables, we have a total of 15 knots here. On ours, we have 2 whole feathers, and since each whole feather is 10 knots, this wind speed has a total of 20 knots. 20 knots. It'll even go, the reference table even goes as far as to give you the conversion from knots to miles per hour. So I could even tell you, hey, so convert this knots to miles per hour, and all you would need to do would be to multiply it by 1.15. All right, I don't have a calculator here, but you could go ahead and do that, and that would give you miles per hour. So you'd be able to do that too, which is pretty neat. All right, and I'm going to continue on. Our precipitation down here is left blank. So what do you think that means if it's just left blank? The precipitation is 0 inches. It is not doing anything. One other little key is this little circle right here. This little circle will be shaded fully to determine cloud cover. So if it's shaded fully, that means this has 100% cloud cover. It means the whole sky is filled with clouds. I left mine completely blank, so the cloud cover is 0%. I have no clouds in my sky. All right, so cloud cover is 0%. In the reference tables, it actually gives you cloud cover that is, it looks like, 3/4 shaded. So if we looked up here, approximate cloud cover would actually be 75% covered. So because it's 3/4 shaded or 75% shaded, the sky is said to be 75% covered with clouds. The last two, and I saved them till the end because they are the hardest, is the barometric trend. Now, if you look over here at the barometric pressure, there's nothing that has a 102. There's 29s, there's 900s, but nothing that's in the 100s. The way that we do this is there's a little rule that we can figure out. And if this is below 500, we add a 10 in front. And if it's above 500, we add a 9. I hope you can read that. A 9 in front. Now, in front probably makes no sense to you. You're like, what is she talking about? Well, this barometric pressure would be 102. And you notice it's below 500. So what I'm actually going to do is I'm going to add a 10 in front of it. But I'm not quite done with it then. I also need to add 1 decimal in, 1 space from the right, and I need to add my units in. So this 102 becomes 1010.2 millibars, which is actually a pretty normal pressure. 1010 is just slightly lower than 1 atmosphere, and you can see it does make this scale, 1010. That's a pretty normal pressure. So that's how we do the barometric pressure. I also want you to notice that on here, on our reference tables, it has a little reminder to us how to convert the barometric pressure. Do you see this 196? I'm actually going to transfer this to my paper over here. 196. Is that below 500 or above 500? It's below 500, so we're going to add a 10 in front of it. Add that decimal, and then add your units. So this pressure right here in our reference tables is actually the same as 1019.6 millibars, what we got right over here, 1019.6. I'm going to do 2 more. I'm just going to jot them down up here. Let's do 999, and let's do 010, okay? So this first one, above or below 500, I'm going to slip a different color in here. This first one, you got it, is above 500. And you remember our little key here, we're going to add a 9 in front. So if it's above 500, we're going to add a 9. We're going to add that decimal, and we're going to add our millibars. So this pressure is actually 999.9 millibars. That's the pressure. But again, it's simplified down on our station model as 999. All right. The other simplified number is 010 on our station model. It's below 500, so we're going to add a 10 in front of it, add the decimal point back in, add your units, and this pressure becomes 1001.0 millibars. All right, so what was 010 is now 1001.0 millibars. So hopefully you can sort of do a few of these practice. I'm going to give you a lab where you practice converting this barometric pressure, and hope that you guys can figure that out pretty easily. The last thing on here is the barometric trend. And one thing I want you to notice is that it's also converted. All right, so some of these are pretty important. So this plus actually just means that it increased, that the barometric pressure increased in the past 3 hours. That's what it means. But how much did it increase? Well, it increased actually 0.2 millibars. And it's this line right here means it's continuing to increase. So if you were asked to do the barometric trend, with this one, you would say it increased 0.2 millibars and it's increasing. That's how you'd read that. So it increased 0.2. All you have to do is add the decimal in and the units, and then you need to read this up line. It's like it's still increasing. So again, the barometric trend is a little bit tricky. So let's do a few more. Let's say you have 20 there. This would be it's decreased. We have to add the decimal in. So 2.0 millibars and decreasing. So it's already decreased 2 millibars and it's continuing to decrease. That's how I'd read. That's how I'd read this barometric trend. I'm sorry, I almost knocked you over. All right, and then so that's a quick lesson on how to do station models. Again, you're on page 13 of your Earth Science reference tables, and that's going to be key for you. I'm actually going to share with you a lab this week where you're going to be asked to do this. The great thing about this lab is it actually brings you through it step by step by step, almost like you're making a recipe in your kitchen. So the key is to read carefully and go step by step and not rush through it, and you should be just fine. The one more tricky little spot is they may ask you what the pressure was 3 hours ago. And this is a little bit tricky because if you think about what's happening with the pressure, why would I care what the pressure was 3 hours ago? Well, I could actually figure it out. If it increased 0.2 millibars in the past 3 hours, then 3 hours ago it was, well, 0.2 millibars less. So if I go to my pressure is now 1010.2. Well, 3 hours ago, it was 1010.0 because it went up 0.2 millibars. So this actually gives us a little bit of a key on what the pressure was. Why would I even care about that? Well, didn't we just talk about pressure and how if the pressure is high, the weather is nice, and if the pressure is low, the weather is crummy. So if this pressure is increasing and it's continuing to increase, that means we're nearing a high pressure and the weather should be clearing. The weather would be getting nicer. So the pressure is really important when we're looking at predicting future weather. All right. So that's weather forecasting in a nutshell. So again, you have a lab coming. I will introduce it another day, but that's where we're at right now. Hope you learned a lot. Bye.